Welcome back again to all the fellow learners of chemistry. Yesterday, we have discovered a new pathway for the movement of electron, hyperconjugation. And to very briefly review that, you see, the pathways that we have earlier discussed, like inductive effect, it's still valid. Mesomeric effect, definitely valid without any doubt. In spite of these two pathways, we realized the totality of understanding about the movement of electrons inside the molecule is not totally explained. We felt as part of co-journey travelers yesterday that there is one more alternative path by which electron movement can be understood. And we have given a name for that. It is called as hyperconjugation. What we have done other day was we have taken a concrete example in the process of discovering hyperconjugation. And what is the next thing we are supposed to do in sciences here? From that concrete example, we must be able to generalize what is the structural requirement for hyperconjugation to operate. The transition is very important from a concrete example to generalization. And what is the next step? As extrapolation from generalization, account for the properties from some new structures. This is a beautiful pathway that normally we encourage in sciences. So we continue again, go back to toluene molecule and try to understand what is the generalization I'm trying to attempt from that concrete example. So let us rewrite again only that relevant portion of toluene that is applicable to construct a generalized structure. So I'm writing a partial structure of toluene now. How does it look like? This is my CH. Of course, there are other hydrogens here. I will write if required, and this is attached to one more carbon. This carbon is part of benzene structure, and this is doubly bonded. This is what I have. As we were insisting in the earlier introductory class also, organic chemistry is essentially carbon chemistry. We do not have many other elements. Majority of the instances, it is carbon that must be carefully be looked into with lot of attention. Any small environmental changes also must be recognized. If you watch out, one of the important environmental changes is for carbon is hybridization. Remember, this carbon has formed 4 bonds here. Therefore, you can easily recognize this is sp3, sp3. And what is the other name for sp3 hybridization is? It is called as saturated. Saturated. Lovely word, because probably we are indicating by that term carbon loves to have valency 4 fulfilled through formation of 4 sigma bonds. It is fully saturated in this environment. If you watch out the next carbon which is double bonded, again, what is the environment of the carbon here? It is sp2. Again, tell yourself and draw that. This is sp2. That means, what is the other name for that? Unsaturated. Unsaturated carbon. That is saturated carbon. Let us be acquainted with both the words. Saturated going with sp3, unsaturated going with sp2. What is the next thing, please? Focus on the saturated carbon now. There must be at least one hydrogen attached there. At least. It means it can be having more than that also. And what is the maximum possibility? 3 hydrogens. So any saturated carbon with 3 hydrogens or 2 or 1, they are capable of showing hyperconjugation. Let's say we have taken benzene molecule. From that concrete example, what is the generalization? This is the generalization. A carbon saturated, attached to at least one carbon, one hydrogen, and carbon unsaturated. So let me write only that much. Now, this is the generalization that I am having in mind. I am drawing it again. This is a carbon hydrogen. So where it is written, are you getting a feel? I am talking about sp3 here. And this carbon, I wish to call this as sp2 now. What are the other bonds here? This is the first requirement. And wherever you are likely to encounter this kind of structure, that means we must be understanding hyperconjugation is bound to operate there. Now, one more point is, because these are the parameters by which we are trying to understand electron movement, whether it's inductive effect or mesomeric and right now hyperconjugation. These parameters can be used anywhere. Anywhere means a neutral molecule or a charged species. Neutral molecule is what? Either a reactant or a product, and charged species either carrying plus or minus, which is part of the transition state. In each and every instance, I think we need to invoke all three of them. But because right now I am talking about hyperconjugation, I will look into only charged species here, not other things here, and also neutral species. So I am having this structure. Now, what is the other thing here? This is the first generalized structure that I can write down here. Other one is, this must be again rewritten, one hydrogen, and the other carbon, now I wish to write down plus charge. That means, is it not unsaturated? What is unsaturated? Not having 4 sigma bonds. So even a carbocation, you watch out, there is a scope for hyperconjugation to be invoked to understand that pathway, to understand its stabilization, to understand its behavior. Or I can write down once more, this is the second possibility, one more structure where carbon could be a dot structure, a free radical. I do not see much difference between C plus and C dot, because in terms of electrons, both of them are electron deficient. And this is unsaturated, this is unsaturated, and this is saturated carbon. Moment you encounter that type of situation, do understand there is a scope of hyperconjugation. And using hyperconjugation, we can as well write down a couple of more resonating structures. And if you remember last time when we talked about resonating structures, if we are able to write down for a given formula more number of resonating structures, greater will be the stabilization. That point is very important. If in case of that, better you refer back to my videos sessions earlier. Now, I will take some examples invoking this kind of generalizations now. Let us imagine I am having in an examination some alkenes being given. Alkenes means CH2 double bond CH2. This is my ethylene molecule. In this ethylene molecule, what I am going to do is I am going to bring about some structural changes here. This is my ethylene molecule, CH2 double bond CH2. Now, one of the hydrogens I am now replacing by methyl group. Methyl group. Immediately watch out, this is sp2, this is sp3, and this sp3 carbon is attached to at least one hydrogen. Definitely the molecule is more stable by this one simple substitution where hydrogen is replaced by CH3. Suppose if I continue working out like this, I will write down one more molecule, CH double bond CH2, and one CH, other CH, and third is a methyl group. Can't you make out easily? This is much more stable compared to this. How many hyperconjugate hydrogens are here? 1, 2, 3. How many in the second case? Only 2. Larger the number of hyperconjugable hydrogens, I can write down more resonating structures. So this is certainly more stable compared to this. If you have followed and if you can extrapolate the argument comfortably, if I am replacing this by methyl group or this by methyl group, so last case where even both the hydrogens are gone and replaced by methyl groups, that means for this sp3 carbon we do not have any directly attached hydrogen. Therefore, no hyperconjugation for that. So let me write down the structure so that everybody follows. So from this structure to this structure, I think this is clear for all of you. I am writing above. I will rewrite the entire thing. The first thing I have written is C, H, 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 and this is attached to CH double bond CH2. Totally there are 3 hyperconjugable hydrogens. Hyperconjugable hydrogens. Second molecule. Again I'm writing CH2 double bond CH2 and this is hydrogen, hydrogen and methyl group. So totally how many hyperconjugate hydrogens are there? Only two. Only two hyperconjugate hydrogens. Here we have three. We have two more possibilities. So again I'm writing CH double bond CH2 C. This is CH3. This is CH3H. Number of hyperconjugate hydrogens are only one now. Relatively this is less stable compared to one. Second, this is third molecule. So one more option is left out. Even that will knock it out. In that case, what will happen here? I will be getting CH double bond CH2. This is C, methyl, methyl and methyl. So what is the fate of this molecule, please? I don't think sp3 carbon has any hydrogens directly attached to it. There is no scope for hyperconjugation here. So you must be able to recognize that. See, one of the good way of asking questions is they will use some structures and they'll try to find out whether you are aware what type of structures can show hyperconjugation. Or they can give these structures like this in a good examination and they'll ask you among these alkenes which is more stable and the reasons for that. If you can master like that, I think you can easily overcome many psychological fears about organic chemistry. Hope this is clear for you. Let me write one more. You see, we have two important reactions that we normally talk in organic chemistry. One of them is elimination reaction and other is substitution reaction. Elimination and substitution. Elimination reaction and substitution reaction. Very popular. Now, I will take one example for elimination and one example for substitution to help us understand about hyperconjugation such that we acquire greater clarity about how it operates in different types of structures, whether the required structural requirement is available or not. Now, in the elimination reaction, I am having in mind to start with. What is elimination, please? Something must be knocked out from the reactant molecule. Something must be eliminated from the reactant molecule such that we get a double bond there. Once we are getting a double bond, recollect, probably could there be some scope for hyperconjugation to operate here. For example, if I am having a molecule like 2 hydroxy group here, 2 hydroxybutane. And what is the elimination I am talking here? The typical type of elimination I am talking is dehydration, where water molecule is knocked out. So along with which, what is the other atom that will be knocked out? It will be hydrogen from the adjacent carbon, alpha beta relation. 2 adjacent carbons are there, therefore I am writing one more hydrogen here. So if this hydrogen is going along with water, that is also dehydration. If this is going with this, even that constitutes dehydration. That means I am trying to understand the dehydration reaction leads to two products. If this is going away, what is this one here? This hydrogen, if it is going away, I am writing this product here on this side. I should get a double bond here between 1 and 2, and this is CH2, CH3. Of course, there is one hydrogen here. This is one butane I am getting. Suppose if this hydrogen is knocked out here, second one, this is pathway, this second pathway. What is the next thing I am getting here? CH3, CH, double bond CH, CH3. I am getting 2 butane. This is 1 butene. Now, which is more stable of these two? And that will be preferred in the reaction. If you watch out, this is 2 butene. This focus on sp2 carbon here. There are 2 sp2 carbons here. Attached to sp3 carbon, that is the structural requirement. And I am having 3 plus 3, 6 hyperconjugable hydrogens. Excellent. That means there is a lot of support for the double bonds from the hyperconjugable hydrogens, and I can write down large number of resonating structures. There are 6 hyperconjugable hydrogens here. Look into this, please. 1 butene molecule. There are only 2 here. These hydrogens are not part of that. I require sp3 carbon directly attached to sp2 carbon. There is only one such sp3 carbon. directly attached to sp2 carbon. So what does it mean? I am having support of only two hyperconjugable hydrogens. Therefore, this will be a major product. The reaction prefers that product because it is more stable. 2-butene is more stable than 1-butene. As a matter of fact, you may be recollecting one more similar reaction, dehydrohalogenation also. In place of this molecule, if I am taking dehydrohalogenation, that is again I am taking carbon with bromine, carbon and carbon. What is dehydrohalogenation? Elimination of H and X, in this case H and Br. Dehydrobromination, for example. So I am having hydrogen here and I am having hydrogen here. This is similar to what we have just now discussed for 2-hydroxybutene. So again I will be getting two alkenes here. If this is going away, I will get an alkene which looks like this. If this goes away, I get an alkene which looks like this. Argument same please. So the answer is also quite obvious. I am sure you will be mentioning the answer sitting in front of your laptops. 2-butene is more stable than 1-butene. Earlier, if you recollect one more thing in a very sharp way, do you recollect Seitzef rule, which was an empirical rule long time back given, which states in a elimination reaction, dehydrohalogenation reaction, we'll get that alkene which is more alkylated. We are getting alkene. And this particular alkene is more alkyl. There are two alkyl groups here. Whereas this particular alkene has only one alkyl group. That is called as a Seitzef rule. Very popular rule. And one of the important contributing stabilization features for Seitzef rule to operate is hyperconjugation. The spelling of that is either they may write like this in some textbooks or they can write it as Saytzeff, Seitzef rule. That is the rule of elimination, which is now better established with the help of what is called as hyperconjugation. One of the important reasons for that. Take one more example. Now imagine the other thing that I was talking is about the substitution reaction. Suppose if you take substitution reaction, there are two pathways for that substitution reaction. Substitution reactions. One is called as SN1 pathway, other is called as SN2 pathway. I am focusing on SN1 pathway because the agenda in front of me is explain and get greater clarity about hyperconjugation for all of us. So in SN1 pathway, what is happening is briefly, my alkyl halide molecule will form R plus in the intermediate state. So I am focusing on intermediate state now to understand the scope of hyperconjugation. Now if it is SN1, our Rx will form R plus. Now what type of Rx molecule will undergo SN1? Normally it is tertiary alkyl halides that adopt SN1 pathway. I will take an example for tertiary halide here. In the case of tertiary butyl bromide, for example, I am having a molecule like this. This is bromine, this is CH3, this is CH3, this is CH3. So bromine attached carbon intern attached to 1, 2, 3, therefore this is a tertiary compound. Now this bond is heterolytically broken and I will be getting what? Carbon with a plus charge because bromine is taking both the electrons and walking out of the molecule. So I am having one CH3, I will write down that CH3 like this, other CH3 and third CH3. This is a transition state. Remember, the choice of the pathway and the speed of the reaction depends upon the transition state only. Now if you watch out plus charge, please tell yourself any charge is not stable and good for the molecule. So what is the attempt of the molecule initially? Do we have the infrastructure to minimize the plus charge? If the plus charge is becoming less and less intense, that means it can easily be formed, easily reachable. Apart from the inductive effect, 3 plus I groups that we are aware of. Do you realize this is again sp2 carbon and this carbon is sp3? The structural conditions are satisfied. Therefore, hyperconjugation is certainly possible. I am having here 3 hyperconjugate hydrogens, 3 more here and 3 more here, totally 9 hyperconjugate hydrogens. So apart from inductive effect, 9 hyperconjugate hydrogens are there which will definitely try to minimize the intensity of the plus charge. That is the reason our tertiary bromide prefers to follow SN route wherein R plus is clearly formed. Because it can take care of the plus charge, no tension for the molecule, it can try to minimize that. So this is one more classic case of hyperconjugation operating. So whether it is elimination reaction or substitution reaction or as a ground state property, I think hyperconjugation must be kept in mind. So very quickly, apart from isomeric as a first string, then below that we have hyperconjugation and also for the preliminary requirements inductive effect. If you can look into all the three things, I think we are having a fairly good view into the interior of the molecule. That is the main attempt of this video sessions. Hope all of us have learned something with greater clarity now. We shall continue. Thank you.